What's up guys, today I'll just be showing you how to set up a basic player controller for Godot 4.0. In this video I'll just go over all the basics like setting up an input map with 4-way movement and also collisions. So the final product will look something like this. You'll have a player which you can move around and all the collisions work correctly, as well as sliding across collisions without getting stuck. Now there is one thing I'd like to note. I am using Godot 4.0. So if you are using any previous version of Godot, there are a lot of things that are different about previous versions for this system specifically, so most of the things in this tutorial will not work. But if you are interested in using Godot 4.0, which I would highly recommend as the program is getting a lot more stable and is actually really close to alpha release, then this system should work perfectly and it's very expandable and easy to use. So we'll just get right into it. So right off the bat, I'm just going to start a new project here. I'm going to expand these a bit so you can see what's going on. And first thing we're just going to do is set up a couple basic things that we'll need. So we'll get a world scene set up, save this in a new folder, and we'll select that as the current scene for running. Now we'll also need to set up the input map for this project. So go to project settings, go to the input map tab, and we'll create a couple new actions. So the first one will be move left, then we'll do move right, move up, and also move down. Now inside of these actions you can add a couple keys. I'm just going to use the keypad for this, so for the left one we'll do the left key, right will be the right key, and so on. Now once these are all set up, you can go ahead and close this, and then we'll create a new scene for the player. Now something you might notice, in previous versions of Godot, the typical node we'd use for player movement was called a kinematic body, but instead it has been renamed to a character body 2D. So go ahead and select the character body, and we'll need to create a collision shape for this as usual. So we'll write collision shape, create a new one, and we'll make a sphere or a circle. We're going to expand this a bit. We'll add some visuals just to see what's going on. So I'll make a new child node here. It will be a sprite, and we'll quick load here the icon, which is built into all the base projects. Now we're going to drag this collision shape in front just so we can see this, and we'll make it a bit bigger. That should do. We'll rename the scene to player and save it in a new folder called player. And we should have all the basic stuff set up and we are ready to code. So we'll add a new script to the player, create, and it will give you a bunch of default code for creating a platformer script. We don't need any of this, so just delete it all. Make sure you keep the class obviously at the top. And we are going to create 4 different variables at the top of this script. Now they will be export variables, so we can edit the values for the player movement later on, and it will be a lot easier. But there is one thing to note, and that is in Godot 4.0, you need to write the @ sign before writing export. So we'll write @export var. This will be called max speed, and we'll set it equal to 300. We'll do another export variable. This one will be called acceleration. We'll set it equal to 1500. And then we'll do another one, which will be called friction. We'll set this one equal to 1200. And then we'll also need an onReady var. So we'll write @onReady var, and this will be called axis. We'll set it equal to a vector2.0. Now once this is done, we'll need to initiate our physics process function, and inside of here we'll just pass for now. Next up, we'll create an input function. So we'll write function get underscore input underscore axis, and inside of here we're going to edit our axis variable to reflect the user's input. So we can write axis.x equals int, open this up, and write input.isAction pressed, and the action we're looking for is move right. We'll then close this, and we can actually just copy it because we're going to subtract the move left action from the move right. So the final code will look something like, if the right action is pressed, it will return a 1, otherwise it will return a 0. It will then subtract the value of the left action being pressed, which will actually change this to move left from that, so we get an absolute value for the direction that the player is trying to move. And if you're trying to move both directions at the same time, it will return 0, therefore not moving the player. Now we can actually just copy this entire thing, and we're going to paste it right here, and all we need to change is the axis.x needs to be axis.y, and then we'll change move right to move down, and move left will get changed to move up. Next up, we'll need to create a function called move, and inside of here we will need delta so that we can sync our movement to the frame rate. And the first thing we'll need to do inside of this function is set the axis equal to get input axis. Now we'll check if the axis is equal to vector2.0, which would mean the player is not trying to move anywhere. Then we will need to apply friction. But for now, we'll just pass, and we'll leave a note here, apply friction. And then we'll write else pass, and this will be where we apply movement. Now, after we use these different options to alter the velocity, we will need to write move and slide, and this will actually apply the movement of our player in the real world and slide them across any collidable objects. Now, you might notice that the move and slide function has changed from Godot 3.0. You no longer have to pass in your motion vector, as the variable velocity is now built into the character body class. So we literally just have to write move and slide and everything will work properly. But lastly, we obviously need to set up the motion and friction functions. So first up, we'll do the friction. Down here we can write function, apply friction, and we'll need an amount. And then inside of here we'll say if velocity dot length is greater than the amount we got, then we will say velocity minus equals velocity dot normalized, and then we will multiply this by the amount. And then we can write else down here, and we will write velocity equals vector2 dot 0 to reset our velocity if our friction has successfully applied all the way to the motion of 0. Next up, we will add a new function called apply movement, and inside of here we will require an amount, but we are going to call this accel, which is short for acceleration. It's just easier to type, and we'll only need two different lines in here. So the first one will be velocity plus equals accel, which will add our acceleration to the velocity, and the next line will be velocity equals velocity dot limit length, and we will pass in the max speed, which is defined at the top. Now you will also notice that the function clamp actually got renamed to limit length in vectors. So instead of writing clamped here, we will have to write limit length. That is another change in Godot 4.0, but it does make a bit more sense, I guess. It's easier to figure out what's going on there, but essentially we are just clamping the value of our motion at the defined maximum speed, which is 300. And once these two functions are created here, we will actually need to put them into our logic in the move function. So first up, the apply friction one, we will type apply friction, and then for the arguments we'll do friction times delta, and then in the movement section we'll apply movement, and inside of here we'll do axis times acceleration times delta. So we'll be multiplying the direction we're trying to move by our acceleration up here, which is 1500, and then also multiply that by delta to sync it to the frame rate. And lastly, we'll need to actually call this function inside of our physics process. So up here we'll just write move and make sure to pass in delta. And that's all we'll need for the player script. So we'll go to the main world scene and instance the player scene up here, go to 2D view, and I'm just gonna drag this to the center so we can see what's going on. And we'll also create a new static body up here, just so we can test out the collision for the player. And we'll need to provide a collision shape. We'll actually do a collision polygon. We'll just add a couple points here. So I'm just gonna create a basic shape. And to see this in our gameplay, we'll actually need to go up to debug and say visible collision shapes. Now if you go ahead and run the game, so we actually got an error here. I completely overlooked this, but up here where we're getting the input axis, we actually need to return the values that we set. So we're trying to set the axis to the get input axis, but we aren't returning a value, so it will be null. So right under here we'll just write return, and we will return the axis dot normalized, and now it should all work properly. So restart this, and you can see everything is working properly. We can move the player around, collide with the object that we placed in the world, and we can slide along it without getting stuck. Now, if you want to change any of the values like the player speed or the player friction, you can just go into the player scene, select the main node here, and under the inspector tab, we can change all of our variables through the export variable system, just like this. So if we set the max speed to, let's say, 500 and the acceleration to something like 2000, we would move a lot faster in game here, and it's very easy to adjust these values, and it's a very flexible system. But with that, that's all we'll need for this system. If you learned anything new or found this video helpful, make sure to leave a like and consider subscribing. But with that being said, thanks for watching the video, and I'll see you in the next one. Bye.